This is section 9.1 video on midpoint and distance formula. So really there's no vocabulary. We just have our two objectives. Find the midpoint of a segment on a coordinate plane and find the distance between 2 points of a coordinate plane. So let's first start with the midpoint formula, something you should already be familiar with. So it says if a line segment has endpoints x1, x2, and x1, y1, and x2, y2, then the midpoint of the segment has the coordinates m is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It's just simple as a formula. So let's look at the first example. They want us, and we're going to be on, let's put the right page here. All right, page 593. So they tell us find the coordinates of m, the midpoint of, which is the midpoint of JK, segment JK, for J is -1, 2, and K is 6, 1. So to find the midpoint, we first have to identify x1, y1. Again, it doesn't matter which set as long as the coordinates match. So, for instance, 6 could not be x1 and 1, y2. They have to be both x2, y2 or x1, y1. Then we simply say the midpoint is equal to -1 plus 6 divided by 2, comma, 2 plus 1 divided by 2, which we get 5/2, comma, 3/2. And that is the midpoint. And remember, it's a coordinate, so you leave it in coordinate form. And you can leave it as improper fraction. All right, so basically we're finding, we have two lines, J and K. We're finding what is the coordinate halfway in between. That is what the midpoint is. So now let's look at the distance formula. The distance formula is the distance between any 2 points on a number line. So remember, the absolute value of a minus b or b minus a gives us the distance between 2 points. We can use this fact and the Pythagorean theorem to derive the distance formula between 2 points on a coordinate plane. So we can follow along here. So they said let D represent the distance between the coordinate x1, y1 and x2, y2. So we use Pythagorean theorem, c squared equals a squared plus b squared. So here's our little triangle. D is the distance between the 2 points. So we have d squared equals, so now remember this is a difference between y2 minus y1, and here it's a difference between x2 minus x1. So we put that in here. Of course, we have to take the absolute value, squared. So we get this. And then to solve for d, we take the square root, and hence is our distance formula. So our distance formula, and these are ones you have to memorize, is going to be distance equal the square root of x2 minus x1 square plus y2 minus y1 square. And technically, it doesn't matter if you did x1 minus x2 here and y2 minus y1 here, because the signs not really matter, because when you square it, it becomes positive, whether it was the result was positive or the result was negative. So it does not really matter. But just to keep straight so we don't confuse ourselves, and since slope is y2 minus 1, let's just keep that same order. So let's look at an example. 2. It says, find the distance between 2 points. It says Troy's disc is 20 feet short and 8 feet to the right of the basket. On his first putt, the disc lands 2 feet to the left and 3 feet beyond the basket. If the disc went in a straight line, how far did it go? So basically what they're saying is we have a line. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right? And then 1, 2, 3, 4, 5, 6, 7, 8. So if we think that this is the basket, so it went short negative 20, right? And 8 feet to the right, so we're talking this coordinate is negative 20, comma 8. And let me do a darker color. And then it said when he put from here, it went 2 feet to the left and 3 feet beyond the basket. Right here. So they want to know how far did, if the disc went in a straight line, how far did it go? So they want the distance between here and here. So remember, this is negative 2, comma 3. So we use our distance formula. So we're going to say x1, y1, x2, y2. So we're going to do negative 20 minus negative 2. Oh, I've got these backwards. 8 comma negative 20. So we have 8 minus negative 2 square plus 20 minus 3 square. All right, so then we have the square root. So this becomes plus, that's 10 squared, which is 100, plus, this is 20 minus 3 is 17, square is 529. We add them together, we get square root of 629. So you're going to use your calculator. So it went about 25 feet. You round. Okay? Pretty easy. It's just a formula. Let's look at example 3. It says, so there was our example there. Now example 3. It says a coordinate grid is placed over a Florida map. St. Augustine is located at 313. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. At 3, comma 13. This is St. Augustine. And then Rockledge is 8, negative 1. 4, 5, 6, 7, 8, negative 1. And this is going to be Rockledge. And then halfway between is Port Orange. So they want to know which is the closest distance, A, B, C, or D, in coordinate units from St. Augustine to Port Orange. So remember, if this is halfway, we can use either coordinate, right? So the first thing we want to do is we want to find this coordinate and then find the distance between, or we can find the distance between the whole thing and divide it by 2. So we start with the midpoint. We said this is 8 comma negative 1. So we said 3 plus 8 divided by 2 comma 13 minus 1 divided by 2. We get 11 over 2, which is 5.5, comma 12 over 2, which is 6. There's our midpoint. Now we want to find the distance between either one. So this is a two-step process, or we could have found the distance between here and here and divide it by 2. We'll get the same thing. So let's just practice using both. So we take the square root of 8 minus 5.5 square plus negative 1 minus 6 square. We take the square root, so this becomes 6.25 plus 49. This together it becomes 55.25. And again, we just put this on our calculator and we get it's approximately 7.43. All right, so it's just about using the formulas, knowing the distance formula, and knowing the midpoint. Do your problems, and we'll see you in class.